My name is Ferhan Mazher, and today in this live session, we are going to do the exercise 8E, and this is our first episode in this exercise. The chapter number 8 is about the further differentiation, and this exercise is about the practical applications of the connected rates of change. And this is the course book of the Pure Maths 1. We are working on the paper 1 of the AS A Levels Mathematics 9701. So let's start, and let me show you the question first of all. And here we go. The question number 1 we are going to attempt. A circle has a radius r centimeter and area a centimeter square. The radius is increasing at a rate of 0.1 centimeter per second. Find the rate of the increase of the a when the r is equals to a. So this is the question number 1 which we are going to attempt. Okay. So in the question, and this is the question number A. He says the radius is increasing at the rate of this. Okay. The dr by the dt is given, that is 0.1 centimeter per second. Okay. Find the rate of increase of the a. dA by dt is question at r equals to 4. So they are talking about a circle has a radius of r centimeter and the area of a. You know the formula which relates the area of a circle and the area and the radius. The formula is very simple. The formula is a equals to pi r square. The formula is area is equals to pi r square. So what we will do, first of all, we will differentiate the dA by the dr, and that will be pi into 2 into r, and dA by the dr will be equals to 2 pi r. Okay. Now at r is equals to 4, the dA by the dr will become 2 pi into 4, and that will be 8 pi. Okay. Now their question is find out the value of, sorry, here we have question mark. Okay, now their base question is dA by dt. dA by the dt will be equals to dA by dr into dr by the dt. This is my chain rule. So because I want to find out dA by dr and dA by dt, so I will apply the chain rule. dA by dr, its value is 8 pi. Its value is 8 pi, and the value of the dr by dt is 0.1. So it will be basically 0.8 pi. So their question was, what will be the rate of increase of the a when the r is equals to 4? So this is my answer, sir. Let me check the answers. This is exercise 8E. I have not opened the answer yet. Exercise 8E. Exercise 8E. And it says 4 pi by 3. 4 pi by 5 centimeter square per second. Okay. So I can convert this into fraction. This will be 8 by 10 pi. This will be 4 by 5 and pi and centimeter square per second. So this will be the answer, sir. And let's do the, I hope you understand this question number 1 of this exercise. It's very easy, straightforward question. Okay. So this is how you do the question number 1. I hope it's clear to you. So let's go to the next question. The next question showing up on this is the question number 2. Okay. Let me show you the question and then we will. Okay. So the question number 2 is, here it comes in front of you. He says a sphere has a radius r centimeter and volume v centimeter cube. The radius is increasing at a rate of 1 by 2 pi centimeter per second. Find the rate of increase of the volume v is equals to 36 pi. Okay. So this some basic information is given. The dr by dt is given and dv by dt is question. Okay. And when the v is equal to 36 pi. Okay. From there we can find the value of the r. Okay. So the basic thing which is given to us is that we have a sphere. This is the question number 2. So we are talking about a sphere. Okay. And the dr by the dt is given. That is 1 divided by the 2 pi centimeter per second. It is given. The value of the volume is given, that is 36 pi. And we want to find out the dv by the dt. That is the question to me. Okay. You see, this volume is given to me 36 pi. From here, I can find out the value of the r. You know the volume of the sphere in your O levels you have studied. The volume of the sphere is 4 by 3 pi r cube. So you know the volume of sphere is 4 by 3 pi r cube. So that is volume of sphere is 36 and pi. So this is 4 by 3 pi r cube. Pi will be cancelled. So you will have the r cube will be equal to 36 into 3 divided by the 4. So r cube will be equal to 27. So the r will be equal to 3. So the value of the r is 3. Now I know the v is equal to 4 by 3 pi r cube. Okay. Now I will differentiate it. So I now know the value of the radius. Okay. Because the volume of the sphere was given, that's 36 pi. From there, I found the value of the r. At this value of the r, which is 3, r equals to 3. At this value of the r, we have to find out the rate of change of the volume. So dv by dt is the question. So I will differentiate it. dv by the dr will be equals to 4 by 3 into pi into 3 into r square. So dv by the dr will be equals to 3 cancel 4 pi r square. So at r equals to 3, the dv by the dr will become 4 pi. The r value is 3, then 3 square. So it will be 4 pi into 9. So that's 36 pi. So that is the dv by the dr. Okay. Now, at the value of the r equals to 3, the dv is equal to this. Now we will apply the chain rule. According to the, the chain rule says that the because you want to find out dv by dt. So according to the chain rule, dv by the dt will be equals to dv by the dr into the dr divided by the dt. The value of the dv by the dr at the r equals to 3 is 36 pi. So that's 36 pi into the dr by dt is already given, 1 divided by 2 pi. So pi will be cancelled, 2 and 36 will be cancelled, you are left with the 18. So dv by the dt, that will be equal to 30 centimeter cube per second. So these are the units. So let me check the answers. This is exercise 8E. And it's question number 2. Its answer is 18 centimeter cube per second. So this is how, my dear students, we will do the question number 2 of this exercise. And now, next question. That's the question number 3. Today, we are solving the exercise 8E from the course book of the Pure Maths 1. This is our first episode on this exercise. The topic of this exercise is the practical applications of the connected rates of change. The topic of this chapter is further differentiation. Is the content of the paper 1 of the Cambridge International ASA levels, Mathematics 9709. My name is Ferhan Mazher, and I'm from Sargodha, Pakistan. So let's start. Question number 3 we will attempt. This question 2 was easy. The question number. Now we are going to attempt the question number in the exercise 8E. And you know the 8E is the last exercise of this chapter 8. So there are total 13 questions in this exercise. So once we are done with this exercise, so our topic of derivation will be completed from the pure one. Then we will start working on the integration. So now the question number 3, let me show you the question number 3 on your screen. Okay, so here we go. Question number 3. A cone has a base radius r centimeter and a fixed height of 30 centimeter. The radius of the base is increasing at a rate of 0.01 centimeter per second. Find the rate of change of the volume when the r is equals to 5. When the r is equals to 5. Okay. So question number 3. So they are basically talking about cone, and they say that this is a cone. That they are not made the diagram, but I am just making to show you. So this is my radius, and this is that height. This is the height. Okay. He says that a cone has a base radius r centimeter, fixed height of 30 centimeter. Okay. The radius of the base is increasing at a rate of, the height is fixed and that is equals to 30 centimeter. And the radius of the base is increasing at a rate of, the dr by the dt is 0.01 centimeter per second. And find the rate of change of the volume, dv by the dt is question. And he says that at r 5. Okay, at r equals to 5, we have to find out the rate of change of the volume. Okay, so very simple, straightforward question. And the formula for the volume of the cone is 1 by 3 pi r square h. Volume of the cone, very famous formula, 1 by 3 pi r square h. We have studied this, we have worked on the volume of cones in our Cambridge O-levels mathematics 4024. And here we are going to use that formula. So V is equals to, basically V is equals to 1 by 3 pi r square. The value of h is fixed, that is 30. So the V will be equals to become 10 pi r square. They told us in the question that the value of the height of the cone is fixed here. So I will put the h equals to 30 centimeter. So the volume is equals to 10 pi r square. Now we will differentiate it, the volume with respect to the r. So dv by the dr will be equals to 10 pi into 2 into r. So dv by the dr will be equals to 20 pi r. Okay. So the value of the r is given. So at r equals to 5, the dv by the dr, that will be equals to 20 and pi, the radius is 5. So this will be 100 pi dv by the dr. Okay. Now we know. So you see we have differentiated it, and the dv by the dr, that's 100 pi. So now we can Apply the chain rule because we want to find out the dV by dt, the rate of change of the volume, and dV by the dt will be equals to the dV by the dr into the dr by the dt. This is my chain rule. So we will apply this chain rule. dV by dt is equals to dV by dr, and that's equals to the you see, the dV by dr into the dV dr by dt. Okay, so dV by dr, its value is 100 pi, and the dr by the dt, its value is 0.01, and so 100 cancel. So its answer is pi centimeter per second. So the value of the dV by the dt is pi centimeter cube per second. So let me check the answer, sir. The answer is pi centimeter cube per second. So this is how you will do this. And we have done 3 questions in this live session. I hope that you will have learned something from this session. And if you think that this video is helpful to you, and it can be helpful to your friends and junior students or to your cousins or the students of A levels, please share the link of this video with them. Okay, please like this video. Please share the link of this video on your WhatsApp groups, on your Facebook, on your Instagram, on your TikTok, on your X, on your other social medias, whichever you are using. You see, when you do this, this thing support my work. Your support is very, very important for my work. I hope that this video will be very helpful to you. We were working on the exercise 8E. This is our first episode on this exercise. This is the solution of the course book, Mathematics Pure Maths 1, Cambridge International ASA Levels Mathematics 9709. The topic of this exercise is practical applications of connected rates of change. In few episodes, we will complete this exercise. Thank you very much, sir. Have a good night. God bless you all.